we're going to be learning about how to use a geoboard. But first off, we're going to talk about a geoboard is a manipulative used to explain the basic concepts of plane geometry like area, perimeter, and properties of polygons, just to name a few. If I was going to use a geoboard to explain advanced mathematical concepts, I would use it to explain how to do properties, how to do like transformations with different polygons, so the kids can have a chance to see how to manipulate and think outside the box. Now, first, we're going to create a rectangle, 4 by 5. So we're going to take the white rubber band, and then we're going to stretch this to 4. Got 4 spaces, 1, 2, 3, 4. And then we're going to stretch the other side to have 5 spaces. So 1, 2, 3, 4, 5. So here, now that we have this rectangle, to find the perimeter, you're going to count all the spaces on the outside. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. So the perimeter will be 18 inches around the sides. To find the area, we will count the number of squares inside. So it'll be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. A faster way we can do that is to multiply the number of sides from the length by the sides on the width, and that would have gave us 20. Now, we're going to show this by creating a triangle inside this. So we're going to create a triangle inside our rectangle that's going to be half the rectangle. Okay, so this triangle represents half the rectangle. As you can see that both sides are the same. So the perimeter of the triangle will still be 1, 2, 3, 4, 5, 6, 7, 8, 9, the 5 and the 4. But in order to find this long side, you have to use the Pythagorean theorem. So a squared plus b squared equals c squared. So 4 squared equals 16, 5 squared equals 25. So that makes 41. And so that would make this one the square root of 41, or about 6. It would be about 6.2 something. It'd be about 6.4. So the perimeter of this would be 4 plus 5, which is 9, plus the 6.4 is about 15.4. And to find the area, you use the formula for the triangle 1/2 base times height, where we have the height as 5 and the base is 4. So 1/2 times 4 equals 2 times 5 we equal 10. And as you can see that since this is half of this rectangle, that the area being 10 is half of how much the area of the rectangle was. Now we're going to make a pentagon. Okay, so now we made our pentagon. And we're going to try to find the perimeter of this pentagon. Notice how we have these diagonals here, which kind of hard to find those based on this shape. So what we have to do is we have to cut this into triangles. So we take this one, now we have this triangle. We have that triangle. Okay. And so we see that we made quite a few different triangles. And it's going to make one more, or another set of triangles. Okay, so now you see I made this in 1, 2, 3, 4, 5, 6 triangles to show the different triangles that can be cut into. Now, so to find the perimeter of this right here, you will have to use the Pythagorean theorem because now we know that this is 2 and that is 2. So we need to find this side here, which would be 2 squared plus 2 squared equals 4 squared. So this would be the square root of 8, or it would be 2.82. So we know that this is about 2.82 plus 2.82 because these two triangles are congruent. Then we have this side here, which is 1, 2, 3. 1, 2, 3. So that's 6. And then 1, 2, 3, 4. So we have 6, 10, plus the 5.6 from this one and that one. So we have it at about 15.6 as our perimeter for this pentagon.